Hello, in this video we will look at how do we find present value of uneven cash flows. Well, we have a series of cash flows which are uneven. Okay, let's look at the first question. It says Jay wants following amounts at end of each year for his education. What lump sum should he invest today if the rate is 9%? So basically, the question says Jay needs 25,000 rupees at end of year 1, 35,000 at end of year 2, 45, 60 and 65,000 at end of year 3, 4 and 5. Now because cash flows are uneven, we can't use them as PMT. So we can do two things. First, we can find out present value of each individual figure. Let's see how do we do that. We need 25,000 rupees after 1 year. So we can put it like this. Present value where rate is 9%. N per is 1. We'll take it from the column B1. B4. There's no PMT. And future value is 25,000. And since there is no PMT, we don't need type as well. So the answer comes to 22,935. So you invest 22,935.78 rupees in order to get 25,000 after 1 year. Now let's drag it down to get figures for other cells also. So if you click on it, you'll find that this has been calculated for 35,000 to be got after 2 years at 9% automatically. So you need 25,458 to get 35,000 after 2 years. Similarly, the figures below 42,245 is what is needed so that it grows at 9% to become 65,000 after 5 years. Now, let's sum it up. So basically, the amount of money that needs to be invested is 1,71,893, which is basically the total of all these monies. Now this is one option. We have another function which will make our job quite easy, and that function is called as net present value. NPV function can be used when the amounts are different but rate of interest is same throughout. Now how do we use this function? Very simple. Just type is equal to NP and V, 3 letters, NPV, open the bracket. It will ask us for rate, we'll key 9%, and then it asks us for values. We can click value one by one, when first value in value 1 comma value 2 so on, but that will get quite tedious. So there's a better idea. So we put in the first cell number, which is C3, C4 colon and the last cell number. So basically this denotes we want NPV starting from C4 to all further years in C8. Remember, few things important to remember are the first column should be the column which is exactly after 1 year. So in case you don't have any value at the end of year 1, you will have to start with a 0, because your first value has to be value of year 1, second value has to be value of year 2 and so on. As you see, your answer is still the same. Now in this case, we have had Jay withdrawing money at end of each year. However, if Jay needs money at beginning of each year, which is beginning of year 1, which basically means now, beginning of year 2 and so on, then what do we do? Let us do a quick calculation on this sheet. It basically tells us that I need, or Jay needs 25,000 rupees right away, which is beginning of year 1 or year 0, 35,000 after year 1, 45, 60 and 65,000 in subsequent years. So we can do the same thing again. Let's find PV of all figures is equal to PV, wherein rate is 9%, N per in this case again before, so that is 0. So basically present value of 25,000 right now will be 25,000 only. You will note the answers are coming in negative because it is a practice to denote all cash outflows as negative. This negative figure basically means that this money is going away, and the positive figure means that those are the monies which will come in. So money being invested will always be shown as negative money because as of now it is going away from your pocket. So since you require each lot of money 1 year earlier, you have lesser amount of interest getting accumulated, and hence as a result you require money more than what you required earlier. Now how would we do this with NPV function? Now remember, as I had told you just a while ago, that in NPV the first value should be value at the end of year 1. So while calculating NPV we will ignore the first value 9%, and then straight on we'll take values from 35,000, 45,000, 60 in order. So year 1, 2, 3 and 4. That's 1,62,364 plus 25,000 what we need right away. So present value of 25,000 is 25,000. We have already got value or amount to be invested, so that I can get 35, 45, 60 and 65,000 at end of year 1, 2, 3 and 4. Plus let's add 25,000 rupees right here to get 1,87,364.34 as shown here. So this is how NPV function helps us. Hope you have enjoyed and liked the video. Thanks.